Hi, hi, this is Skylar Hall, and I would like to demo my computer architecture final project. Um, what you are looking at right here is the FPGA board that I purchased. It's called the RDS7, and the program that the architecture that I created is actually running right now. Um, I'll go ahead and explain that here in just a moment. But you can see the LEDs are flashing at the top there. There's 4 different LEDs and it's running through some different sequences. So you may ask yourself, okay, awesome. You have 4 LEDs that run through a couple patterns. What's the big deal? So let me go ahead and explain that, and I can show you real quick. Okay, so I've got my design pulled up here. So let me just start by saying, kind of explaining what's going on here. Uh, So this board that I have demonstrated is what you call an FPGA. So how is it different from a normal microcontroller? Well, microcontrollers in general tend to have a fixed, limited, and simple design. What would you do if you have a need that doesn't meet that fixed architectural design? Um, for example, like a microcontroller like an Arduino, right? Um, Well, without actually purchasing some more expensive board, you're kind of out of options. There's no way to change the architectural design of an Arduino. What if you wanted to create a project that includes a VGA display or something with more memory, something that has a higher clock rate? Um, well, that's kind of where an FPGA comes into play. An FPGA is a field programmable gate array. It is a device that contains little individual logic cells that are reconfigurable, that are programmable. Um, it's a fancy way of describing what is really a wild card in the world of development boards. Um, one way to describe it is if you have the task to mow a lawn. Well, a microcontroller would be like your normal lawn mower, whereas an FPGA would be like a box of Legos that you could then build a lawnmower with. If you wanted that lawnmower to suddenly become a race car, you could do something like that. Um, Now, the project that I created, I went through and demonstrated that you can create a microcontroller in an FPGA. The name of my project is The Evolution of a Microcontroller in an FPGA. So really the steps it took for me to be able to complete this. Now, the processor that's in my microcontroller, the processor that's in my FPGA is a normal open source processor. I didn't write it. It's called a MicroBlaze processor. However, the system to actually control that processor, I did go through and create. Um, I went through and wrote this in a program called Vivado. That's what they recommended for this particular board. There's 2 different ways to program this board. You can either program it through code, which I'll show you the code here in just a moment, or you can actually go through and create a schematic and it'll actually generate the code, and that's what I have chosen to do. Now there's still a lot of configuration that goes into something like this. You have to make sure that the processor is clocked at just the right frequency or things may not work properly. Your memory has to be set up correctly. You actually have to go through and set the correct addresses for all of your buses so everything's communicating correctly. There's a lot of work that goes into something like this. Uh, now, um, with my particular design, I have, like I said, the MicroBlaze processor. It is talking to a couple different modules. One of them is uh, this one and this one. These two actually control the memory. This one controls the flash storage that's on the board, and then this one over here is called a MIG controller. It actually controls the RAM. There's 256 megabytes of RAM on this board. And then lastly, there's a couple other ones, but lastly, the one that I'm going to mention is this up here. It's called a AXI bus. It's a fancy way of saying that this module controls the communication to your peripherals, to your I/O, to your pins, your LEDs, your switches, that type of thing. And so I have it actually connected over here to the LED. Now the Microblaze processor is a 32-bit RISC-V processor. It's a very similar processor to the MIPS processor that we've been learning in class, which is why I've selected it. Here is the code for this processor. Now, like I said, I had the system generate this code based off of that schematic design. I'm not going to show all of it, but you get the idea. There's a lot here. Now, once that architectural design is created, there's actually 3 different steps that have to go into loading that onto a processor. Or, I'm sorry, loading that onto an FPGA. First, you actually synthesize the design. What that does is it converts it into like a generalized collection of logic gates. Then what it does is it actually does an implementation design. Now, the implementation design, it will actually go through and take the chip that's on the FPGA and it will select the logic gates and show you what it would look like. It's important for an implementation to occur. And then lastly is actually loading it onto the processor. So this may not look like very much, but let me just show you what's going on here. If I were to go through and zoom in here, keep zooming in here, you can see that there's a lot going on, but you may not necessarily what's going on. Well, these little blue boxes here, these are individual logic cells. You can see that there's a lot of them going on here. Those are actually what's controlling the architecture of this board. Now, once you've created your architecture, what do? Well, you can program your microcontroller just like you would be able to program any others. And this is the code that I wrote to do that. And it controls the 4 LEDs at the top, and it controls it by sending 4 bits of data, so 16 total addresses, and it controls that address. So if I send 1 to it, it turns on the first LED. If I send 1, 0 to it, it turns on the second LED, and so forth. And I have it doing those. So you may ask yourself, okay, why only 4 LEDs? And that's where we get into the exciting part of this presentation where I talk about the problems. Um, for whatever reason, I can only control those 4 LEDs out of all of the I/O on that board. That is the only thing that I can talk to. My guess is those LEDs sit right. Those are the first addresses in the I/O bus. My guess there's a problem with the memory controller. With me being fairly new in the world of FPGAs, I don't know how to actually go through and fix that. And with the time that I was given, this is what I was able to get done. You ask yourself, okay, that doesn't seem that impressive. Would you consider this a failure? I would say no. And the reason I say that is because there's a lot of things that I still have working here. I have a full functioning UART interface. This is a USB interface. You can actually see here it's printing out to serial. If I connect a serial monitor this, or even something like an Arduino, and have it listen in on the serial, you'll see it pull up, and it's a standard serial line. That's working great, and that's, if you read about them, those tend to be a pretty hard interface to actually get working. I worked on this project by myself. I did contact Professor McGowan when I was proposing this project, and that was the arrangement that we came to. And so this was the first demonstration that I would like to demo. There is one other one I would like to demo, and I'll show that here right now. Okay, so I'm going to go ahead and demo the last demo that I am going to do. This is kind of like part two to my project. As you saw in the first demo, I had the LEDs. Well, I wanted some way to show that I can control the I/O. I just can't do it with that processor that I designed. So this is what I came up with. This is a VGA interface. Now I'm actually controlling this directly with Logic, which is which is why you don't see a lot going on here. Creating the colors, those are easy. Creating the lines, those are also easy. Creating a little moving box, piece of cake. Taking something like an image and loading it onto a screen, that's a little bit more challenging. This is what I was able to get working with that. And I'll go ahead and show the code from that just briefly, but I'll show that here in just a moment. Thanks for watching that demo. I hope you enjoyed it. Like I said, that was a demo of a VGA interface that I created. I wanted to kind of just show off the code real quick. I know that I'm short on time, so I'll make this fast. It was originally written by a guy named Arthur Brown. He worked for the company Diligent as a demo for the board. Now it wasn't developed for this board; it was developed for a different board. So I actually had to go through and adjust the timings on this project to get it to actually work with mine. Um, so I'll go through and show you some interesting facts about this. I'm actually running an 800 by 600 at 60 hertz resolution. This requires a centralized 40 megahertz clock. Like I said before, my board does max out at 100 megahertz, so I had to find something that was under that marker, and not all of these resolutions would actually work with it. Now let me show you this real quick. So in the VGA interface, I'm not sure if you guys are aware of the protocol behind it, but it was created for the older style TVs, the ones with the vacuum tube and the laser projector in the back. And what it would actually do is it would project that beam of light and it would draw out a line and it would go left to right, top to bottom. And it would draw out pixel per pixel. Well, in order for something like that to work, they actually had to leave a gap on the left and right side as well as top and bottom. Well, the left and right sides got the name front porch and back porch. Um, and those are actually the same timings that we still use today, even in modern TVs when it comes to the VGA interface. Uh, so I have to include those in here as well, which is kind of interesting. We talk about those a little bit. Where's it at? Right here. So front porch. I think he mentioned something about a max height, max vertical, but there's also a back porch in there too. And then we get down into the code right here. This is actually what draws that test pattern at the top. And then we also have the code for drawing the moving box. Moving box is definitely interesting. You pass in a clock, that 40 megahertz clock. On the rising edge of that clock, it actually performs actions. This just shows you the power behind the FPGA. Um, and yeah, I'm just about out of time. So thanks you guys for watching my presentation. I hope you enjoyed it. I hope you recognize that this took a lot of work and effort. I'm excited to see the rest of you guys' presentations. And you guys have yourself a wonderful day.